dimension, the third aspect to the shape. So if you have a square and you turn it into a cube, it is said to be in 3D. So last week we had one line, linear, how far around a shape it was, perimeter. Area is usually two-dimensional because it's flat. So that is area because we had a side times a side. Now we're looking at the third dimension, which is volume. So in volume you have to have three aspects. So you have your flat surface area times how fat it is. So the formulas from last week will carry on. So if this is an ordinary cube, you know those annoying little wooden things you had at primary school to show ones. So for a cube we would take how long it was, and if this case is a cube, what we know about cubes is that all the sides are the same. So if this was 3 centimeters wide, then it is 3 centimeters tall. And then it will be 3 centimeters backwards. That would be our third dimension. So in order to find volume, we go height times width times how fat the thing is. 3 things. So in this case, it would be 3 times 3 times 3, which would be 27. It's centimeters, and we would write cubed to show that it is a volume. Now that's a cube, and what we know about cubes is that all measurements are the same, because if they're not a cube, then they're not all the same. Then we're looking at prisms. Prisms are pretty much the face shape times how fat it is. So if this was a tent and you were looking to stuff polar bears in there, just making sure everyone's listening, you take the area of the shape that repeats. Now in a tent, the triangle is the shape that repeats. So the formula for the flat of a triangle is half the height times how wide the sucker is. So if this tent, it's a big tent because it's for polar bears, was 10 meters wide, and it was, let's say 12, polar bears are very tall, 12 meters tall, then when we would go 12 times 10, which is 120, and then we'll halve it. So the area of the shape that repeats is 60, I better be meters, squared. Now we need to know how many polar bears we can stuff in here by how long the thing is. So if it's 20 meters long, you want to put a lot of polar bears in there, then we would then times our area by how long it is, which is 20 meters, which would give us 1,200 meters cubed. Now, that's for a prism where the face shape repeats. So another name for a prism is a cuboid, where the face shape repeats. So your Weet-Bix box, for example. Your Weet-Bix box is 10 meters, that's a lot of Weet-Bix, maybe we're feeding those polar bears, and it's 4 meters high. So the area of the face shape is height times width is 40 meters. But we need to add that third dimension of how long our Weet-Bix packet is. And this Weet-Bix packet is 3 meters long because it's got to feed a lot of polar bears. So that is the area of our face shape times how long it is. So it will be 120 meters cubed. Now, the last shape is a sphere. So a sphere is a round ball like a rugby ball. Now, we can't just take the face shape at the front because a tennis ball or a football does not have a flat surface. If it does, stop playing your game because your ball's flat. You have to have a formula, and the formula is 4 times pi, which is a secret number, times radius times radius. So, the radiuses of the ball is the center of the ball to the outside. Like in a planet, it would be the core of the planet till you get to the crust. So, if I was playing football with some polar bears, then it would go 10 meters. Our ball is 10 meters on a radius. So I would have to go 4 times 3.142, which is the secret number, times 10 times 10. So 4 times 100 is 400. 400 times 3.142 is approximately 12 plus 4, 52, 3, 6. So our volume in our big soccer ball that we're playing soccer with our polar bears is approximately 124 meters cubed. Now it's cubed to show that we're looking at a volume. That's it. Hit pause. And your plan there was to distract area and perimeter. Right, so we're going to learn area versus perimeter. Now in the picture you can see I've drawn a square. The square is 4 meters by 4 meters. Now we all know that every single side on a square would be 4 meters. So if a bee travelled all the way around that square, you'd have to add 4 meters